Okay, so now I'm going to show you
now
how
we
to
analyse your
sample
sample
data.
which
So here's you can find this sample data you've already seen. So in this PCR practical, we need to do one more thing. So in this particular measure, how many experiments you want to see what to do in this column here.
We measure
whether
sham
it's
band
bands,
so
the
the
sham
sham
is surgery type, and the outcome is
Now, the
categorical.
next thing we have to
So
consider is what
for a
type of
band.
outcomes
Now, as we've seen,
is that
present or absent.
well, bands are
create a graph
continuous,
by
so
the
what you
there
do
or
in
not.
this, that's
categorical
categorical, so band is either
table
tables
is
to
select
select
vertical bar
numbers.
chart.
How many predictive variables
For example, here in the sham group next, 11 samples. In this case, we have 2 columns of data, and this is referred to.
In this case, we've got one predictor, whether the animals
and then the stroke group
click
next
there,
so it's now asking for your first column of data.
Three samples that
Click
a category of
3 band,
and
the second column of data,
so
so you click 2.
Now you go along here, the only option is different anyway, so we need to analyse here's your graph to emphasise what this is. If a categorical predictor with the same analysis, some of the things you can do, if you double click here, different animals receive stroke. Now you can ask it, again there's all these options to specify column. So the only option for analysing this kind of data is straight away chi-square
test how it was originally, and then columns that run 1 and 2. It's going to ask you how you set your data up. Now in this case we've set this up as tabulated data. Now you can make it's also called a contingency table. Let's say font 2. If you see here, what you need to do is select tabulated data, then you click next. Now suppose and all you do now is you select 2 columns of data. So here's your first column, these click surgery type, you can double click X data and now write surgery type. That didn't work, so you click here to highlight the column, and now it's got column 1. Now in for the next set of observations publication, such as in the British Journal of Pharmacology, you don't need a title on your graph.
SigmaPlot comes up with a little warning, and it's saying you might want to run a tinker with this some more. So for example, you see again in the sham group 11 out of 11 SigmaPlot's lacked an ATF3 band for this. Whereas if you want to understand a little bit more about this, you can consult a textbook to see why you would want to run
contained an
ATF3 band chi-squared test.
So I'll leave you
in this
to
case
figure out how to click on these things to change the colours.
Yes. But
and again, this is where your data was up here. You can change
chi-squared
this wording to number, for example.
So it tells you you ran the chi-squared test that either had or you tried to run the chi-squared test. This was
had or lacked
aborted, and instead
this is your legend
test.
You can click here. You can drag it somewhere useful.
This is your p-value. So there's a highly significant association between
so I would still say this graph is a pretty mediocre and boring graph, and you can do a lot more work to make this appealing to the eye.
This is a nice
colour coding the bars, by changing the axes, perhaps so that 1, 2, 3, 4 is shown all the way up to 12 rather than just the random occurrence. And you can do all this just by playing around with this panel here, or by double clicking aspects of it to highlight what you'd like to change. So I'll leave you to play around with it. This has all the key information.
8 out of 11 contain an ATF3 band for the stroke group. So it's this association that's highly significant. And in a minute, I'll show you how to draw a graph for this kind of data. But what you should be able to see from this table is we don't have any measurement of variability in this study. We're looking at proportions. So in this case, 0 out of 11 had a band in the sham group, and 8 out of 11 had a band in the stroke group. So there's no standard deviation, there's no standard error or confidence interval associated with this data. There are no means. These are just the observations, and that's why we've used a chi-squared test. And this will affect how we present the data graphically in a second.